Good morning and welcome back to more normal science stuff. Today we are going to talk a little bit more about the states of matter and then how those states of matter change. You should be opening your Coriel notes, ready to go, and let's get started. So we have solids. We talked about solids a lot. They're tightly packed particles. These are atoms or molecules vibrating slightly about their fixed positions. We'll talk more about that later. All the atoms are very close together. They are fixed, closely packed, and they have a definite shape and volume, like the desk in front of you. There are two types of solids. The particles in crystals are called crystalline solids, and they form a regular repeating pattern, like a snowflake, or that little piece of, I think it's Byzantium, on the right over there in the picture. There are also amorphous solids, which are things that are solid, but the atoms don't repeat. You don't get the really pretty crystal structures. When a crystalline solid is heated, it melts at a particular temperature, like ice. Amorphous solids become softer and softer, but do not melt at a distinct temperature. Think about most metals. Now, particles in a liquid are packed almost as closely as a solid, but they can move around freely. Because of this, liquids don't have a particular shape, but they do have a particular volume. They will flow to fill whatever container they are in, but they don't get bigger. Viscosity is a liquid's resistance to flow. Think about oobleck. Also, honey has a higher viscosity than water. Much easier to pour water than it is to pour honey, or oobleck for that matter. Liquids have surface tension, an inward surface that brings molecules together. This is why you can float a boat on water. Or, pretty much anything. Last, we have gases. Gas particles, they just move in all directions. They're really spread out. They have a lot of space in between them. They will fill the entire space available. All right? So, the gas has not a definite shape or definite volume. It does have a mass, though. We're not going to be able to take the mass, but it does have a mass. So why did I quickly review all three of our states of matter? Well, I reviewed them because today we're going to talk about changing states of matter, right? Going from one to another. And it's important for you to realize that at room temperature, all of the substances that you are familiar with have a certain way they like to be, right? This is why with ice, we need to make it cold for it to be ice, and it slowly wants to come back to what it wants to be at room temperature, which is water. The change in state happening here with ice from a solid to a liquid is melting. Most pure substances, let's not worry about that. There's a specific temperature at which all of this happens called a melting point. The melting point is a temperature. If you put something in a temperature that is past its melting point, it's going to melt, right? Remember we talked about the Celsius scale. Ice wants to melt past 0 degrees Celsius. Well, if you put it in a room that's warmer than that, it's going to begin to melt. These solid atoms that are very rigidly packed together are going to break apart and turn into a liquid. The opposite of this is freezing, when a liquid turns into a solid. This is when the temperature is below that freezing point. So if I took a glass of water and put it in a fridge below 0 degrees Celsius, it's slowly but surely going to start to to freeze. Vaporization is what happens when a liquid turns into a gas. Vaporization is actually happening at most times to all liquids, just very slowly, right? Vaporization happening on the top, that happens all the time, is called evaporation. This is why if we leave a cup out, slowly but surely there will be nothing left in the cup. Vaporization that takes place in both places, not just on the top, but also in the liquid itself, is called boiling. When the temperature of the liquid is raised to the boiling point, the liquid will boil, and you'll see those little bubbles form in it, and it will throw those bubbles up into the air, and that's actually molecules of the liquid going out. The reverse of this is condensation. This happens when you get a really cold glass and leave it out. Right? The gas in the air actually bumps into the side of the glass, and that molecules start to collect on the outside until you get a lot and enough where you have to wipe it off. As you can see in the picture, it also happens when you shower to the mirror. There's another special case called sublimation. I just like it because the word sublime sounds really cool. This happens when you take a solid that its freezing point is so low that you actually bring it into an area where it's past its boiling point or its vaporization temperature, and the solid goes directly to a gas. This good example of this is dry ice. Carbon dioxide wants to be solid very cold and wants to be a liquid at very cold temperatures. But so when you bring it into a room, it turns right into a gas. That's why we get cool fog machine effects. So, interesting fact, if you are troubled by mosquitoes, mosquitoes are attracted to the carbon dioxide which you exhale breathing. Alright, you can build a mosquito trap with, it's 6:30, you can build a mosquito trap with dry ice and attract so many mosquitoes and get them caught, and maybe we'll talk about that a little bit.